So this is a function type question. What they want you to do here is they actually want you to find the equations of both of these lines, right? So the function or the question asks us to find the equation of f at x. So what is f at x essentially equal to? And then find the same thing for g at x. What is that equal to? And then multiply the two equations. So in order to do this, these are both linear, okay? These are both straight lines. So what we're looking for is y equals mx plus b for both of them. Do you remember what m stands for?
Is it slope?
Yeah, so m is our slope. What is b?
It's the...
Nothing to do with those.
Oh, y?
Yeah, that's right. That's your y, your x. So it's your y-intercept. So we have to find both of those for each equation, right? We know we're going to have y. So let's say for f at x, well, our y-intercept is right here, a value of 2. And we can pretty much look, well, depending on how your question was set up, let's just say that this is another point here, okay? We can find the slope, and this will actually lend to what we're about to do next. Slope of this is you find the two coordinates. So this coordinate is at 0 and 2. And we'll say this coordinate is at 5 and 1. Okay. We can find slope two ways. We can literally just count over. So this would be our run. 1, 3, 4, 5. And then 1 down. So do you know what that slope would be if we were to go over 5 and down 1?
It'd be 1 over 5.
Yeah, 1 over 5, positive or negative?
Negative?
Yeah, that's right. This is a negative slope. So we can literally just look at that and find out. So our slope here is negative 1 over 5. And a quick way we could have found that is we take the two coordinates. So m is equal to y2 minus y1 over x2 minus x1, which is exactly what we're going to do for average rate of change next. So we'll just call this coordinate, we'll call this coordinate 2 and this coordinate 1. Okay, so y2 is 1 and x2 is 2. x2 is 5 and x1 is 0. 1 subtract 2 is negative 1 over 5. So that's exactly what our slope is. We could have found it by plugging into that equation. And our y-intercept was positive 2. So f at x, or y, is equal to negative 1 over 5x plus 2. That's the slope of that line. All right. We would do the exact same thing for g at x. Our intercept is 4. We know that. And we can pretty much count. Let's just go on the assumption that this line, here's the other coordinates. So here's 0 and 4 to make this easier. And this one is 2 and 6. Well, I can just count up over 2, up 2 over 2. So that's going to be a slope of 2 over 2, right? So m is 2 over 2, and our y-intercept was 4. What is 2 over 2?
It's 1.
1. So g at x, or y, is equal to 1x plus 4. So these are our two lines. Okay. Once we found the equations of both lines, we now go about multiplying the two equations. Okay. So our new function, or when we go to graph it, we're going to get y, change the color. Y is equal to f at x times g at x, right? Well, we just plug those equations in. I plug this in for f at x, so I get negative 1/5 x plus 2 times g at x, which is times x plus 4. From here, what do? We have two terms in each bracket. Do you remember what it's called when we're multiplying these?
Do you expand it?
Yeah, you're expanding, so it's distributive property or FOIL, whatever they call it, where you multiply. Sometimes they call it the rainbow method. You multiply first one by both and the second one by both, right? So y is equal to negative 1/5 x times x is negative 1/5 x squared. Okay. Negative 1/5 x times 4 is negative 4 over 5x. 2 times x is 2x. And 2 times 4 is 8. We only have two like terms. Do you know what they are?
The x and x.
Yeah, the x and the x. Well, I'm going to try to make it a fraction just so it's easier to work with. So negative 1/5 x squared. That would be 10 over 2. Or sorry, 10 over 5 if we were a fraction. So negative 4 over 5x plus 10 over 5x plus 8. Negative 4 over 5x plus 10 over 5x is 6 over 5. Okay? So plus 6 over 5x plus 8. So now we have a quadratic. Oops, sorry, this is squared. So we have some quadratic, and then in order to graph this, we're going to have to factor. We can put it into vertex form. There's a lot of different ways we can go about doing this. Okay? In this case, we have a fraction, so we might want to actually, we can multiply, I could say the entire equation by 5. Or we can factor to find the x-intercepts. It's going to take us a bit, but do you understand how to graph this? Or do you understand the steps we've done to get our new function?
Yeah, I get the steps up to that.
Mm-hmm. So now technically we would factor this, okay, or put in the quadratic formula. Once we put in the quadratic formula, we get two x-intercepts, and then we can find a vertex. Do you want to do that?
Yeah.
Okay. So let's go through that part. Quadratic formula, if you remember, is x is equal to negative b plus or minus the root of b squared minus 4ac divided by 2a. Oops. Do you remember that formula at all?
Yeah.
So this is our a, this is our b, and this is our c. Okay? So we got to plug these in. It's going to get a little messy. We'll go back to black here. Our b was positive 6 over 5. So we get negative 6 over 5 plus minus the root of b squared. So that's 6 over 5 squared. Okay. Minus 4 times a is negative 1/5. C is 8. Are these making sense so far?
Yeah.
We're just plugging values in right now. And then 2 times a again is negative 1 over 5. So we're working with fractions here, so we got to remember our fraction rules. I'm going to keep it in fraction form. This becomes negative 6 over 5 plus or minus the square root of. Now, 6 over 5 squared is just 6 over 5 times 6 over 5. So that gives us 36 over 25. Okay? Multiply these. All right, I'm going to quickly do it. Negative 4 times negative 1/5 is positive 4 over 5. Positive 4 over 5 times 8 is 8 times 4 is 32. 32 over 5. So we're adding positive 32 over 5. Are you okay with that?
Yeah.
Okay. And then on the bottom we get negative 2 over 5. Negative 2 over 5. That's 2 times negative 5. We'll equate this fraction here. We'd have to multiply this by 5, so I'm going to equate it without doing the whole step. This fraction is actually the same as 10 carry 1, 160 over 25. Okay, because we have to add fractions, so we need a common denominator. And when I add those fractions together, we're going to end up with 196 over 25, the root of it. Okay? Negative 6 over 5 plus or minus. There we go. There we go. And then negative 2 over 5. So we got to root this term here. We can put it into decimal form when we go to root it. 196 divided by 25. Right? So it's 7.84. And we can square root it. 2.8. Oh, really? That worked out really nice. I wonder if it floats off on this. Anyways, that's probably rounded. 2.8. So, and we can make all the fractions decimals now if we want. We're at plus or minus 2.8. We'll put these all into actual decimal numbers. Okay, so it might be a little easier for you to work with. 6 divided by 5, 1.2. So negative 1.2. And finally, 2 over 5 should give us 0.4. negative 0.4. Because it's a plus or minus, we have to split it. We're going to get two answers, which makes sense because we're going to have two x-intercepts because this is a quadratic. Okay? So we're going to get negative 1.2 plus 2.8 over 0.4, negative 0.4, and negative 1.2 minus 2.8 divided by negative 0.4. These will be our two answers. Okay? Let's try to do this all in one step here. Negative 1.2 plus 2.8 divided by 0.4, negative 4. Okay, that was nice. And then our other one, 1.2, negative 1.2 minus 2.8 divided by negative 0.4, negative 10 apparently. Oh, sorry, was that negative or positive?
It was positive.
Positive? Yeah, I think it was. Positive 10. Okay, so what that's given us are our two x-intercepts. So we did a lot of work there. So when we go to graph this, one of the x-intercepts is here, and the other one's over here. Okay, so our vertex is probably going to be off the chart. Okay, the vertex is going to be directly in the middle of this. Okay, do you know how to find the vertex from here?
It's just the middle.
The middle. So it's called the axis of symmetry. We add these together. So the AOS is we add those together. So negative 4 plus 10 divided by 2. That's how we find the middle. That gives us 6 divided by 2, which is 3. Okay? So the middle of that parabola is at 3, right here. So that's the middle of those 2 points. And then to find out the actual y-intercept, because that's the x, sorry, not the y-intercept, the y value of the vertex, we take that value 3 and plug it into our equation. If you remember, our equation in the end was this. Or this term here. Okay, that was our equation. So we technically take our 3, because we know that's the x value of the vertex. When x is 3, what is y? So we plug it into this. I'll do it on the side quickly. 1 over 5, 3 squared. A lot of work for this one, eh? 6 over 5 times 3 plus 8. 3 squared is 9 times a fifth is negative 9 over 5. This becomes 18 over 5. And I'm going to make this over 5. It's going to be 40 over 5. So we're working with fractions. Negative 9 plus 18 is 9 over 5 plus 40 is 49 over 5. Oh, I guess maybe not. It's just going to be a very wide. And 49 divided by 5, 9.8. So the y value is at, 9.8. So it's way up there. So we go to draw this. We'll say this is roughly 9.8. So now if we were to graph this, these are my x-intercepts. This is my vertex. When you multiply those together, this is the graph we end up with. A lot of work.
Yeah.
Did you follow? Did it make sense, you think?
Yeah.
Yeah.